Hey, before we begin, just a small thing. If something's been sitting on your chest today, some worry you've been carrying around since morning, or maybe longer, you can set it down here. Drop it in the comments. You don't have to explain it. You don't have to make it make sense. Just let it out of your hands for a little while. And tell me, where are you right now? What time is it where you are? I always wonder about that. Who's listening at 2 a.m. in Seoul? Who's lying on a couch in Dublin with the rain outside? Who just got into bed in Sao Paulo? If you're new here, you're welcome to stay. Subscribe if you want. We do this every week. Just stories, just quiet. Now, take a breath. And let's talk about why you had chicken for dinner instead of tiger. Close your eyes for a moment. Not yet. Keep listening, but close them. Now press your tongue to the roof of your mouth. Feel the warmth there. Feel your own heat. That heat is the whole story tonight. Right now, your body is burning through energy just to keep you at 37 degrees Celsius. Your heart is pumping. Your lungs are expanding. Your brain, just by listening to this, is consuming roughly the same wattage as a dim light bulb. You are a furnace, a quiet, breathing furnace lying in the dark. And that furnace has rules. Old rules. Rules written not in any language, but in thermodynamics, in the physics of how energy moves through living things. Rules that determined what your ancestors ate, where they could live, whether their children survive the winter. Tonight, we're going to talk about one of those rules. The most important one you've never heard of. The 10% rule. Here's something strange. Think about the animals humans have domesticated. The ones we've kept close, bred, fed, built entire civilizations around. Cows, chickens, sheep, goats, pigs. Now think about what those animals eat. Grass, grain, seeds, scraps, insects, in the case of chickens, things that grow out of the ground or crawl on it. Now think about the animals we never domesticated, never penned, never farmed. Lions, wolves, eagles, sharks. What do they eat? Other animals. This isn't a coincidence, and it isn't because lions are too dangerous to keep. Humans have caged lions for thousands of years, from Roman arenas to medieval menageries. We could have farmed them. We could have bred them for meat the way we bred cattle, but we didn't. No culture on Earth, in 10,000 years of agriculture, has ever built a lion farm. Not because we couldn't. Because the math doesn't work. There's an invisible law of physics, not biology, physics, that makes it roughly 10 times more expensive in raw energy to eat a predator than to eat a herbivore. 10 times more land, 10 times more water, 10 times more sunlight, ultimately captured by 10 times more plants, fed to 10 times more prey animals, just to sustain one single predator at the top. This is the 10% rule. At every step in a food chain, roughly 90% of the energy is lost, burned off as heat, used up in movement, in breathing, in the simple expensive act of staying alive. Only about 10% of the energy an organism consumes gets passed on to whatever eats it. The grass captures sunlight. The cow eats the grass. You eat the cow. At each of those steps, 9/10 of the energy vanishes, radiating off into the atmosphere as waste heat. The same heat you can feel right now, pressing your hand to your own neck. You are warm because you're inefficient. And that inefficiency shaped everything. Somewhere right now, someone on the other side of the planet is also lying in the dark, also listening to this. Maybe they're in a high-rise in Tokyo, 15 floors above the city glow. Maybe they're in a village in Senegal where the power cuts out at 9 and the stars pour in through the window. Maybe they're in a truck stop in Wyoming, sleeper cab, engine ticking as it cools. You don't know them. They don't know you. But your bodies are doing the same thing right now. Burning energy, generating heat, breathing in and breathing out. The same ancient furnace. The same 37 degrees. Stay with me if you want. Sleep if you need to. Either way, you're in the right place. The story will be here. It doesn't need you to stay awake. It just needs you to rest. The year is 1942. The place is a lake in Wisconsin, though you wouldn't recognize it as a laboratory. Cedar waxwings call from the birch trees. The water is dark and clean and cold enough to ache. A man named Raymond Lindemann is dying. He doesn't know it yet. Or maybe he does, in a way that a body knows things the mind refuses to say aloud. He is 27 years old. He has hepatitis, and the treatments of the 1940s are bed rest and hope. But before his body fails him, he is trying to finish something. A paper. One single paper that will change how every ecologist after him understands the living world. Lindemann has been studying this lake. Cedar Bog Lake, they call it, though it's more marsh than lake, more mud than water. He has spent years crouching at its edges, collecting samples of algae, counting the tiny crustaceans that graze on the algae, cataloging the sunfish that eat the crustaceans. Patient, tedious, ankle-deep work. The smell of decomposing plant matter. The feel of cold mud pressing through the canvas of his shoes. And what he's found is a pattern. A brutal, elegant pattern. The sunlight hits the water. The algae capture it, but not all of it. Most of the light bounces away, or passes through, or arrives as wavelengths the algae can't use. The algae keep maybe 1% of the sun's total energy. Then the tiny animals, the zooplankton, the water fleas, eat the algae. But they don't get to keep all of what the algae stored. Their own bodies burn most of it just staying alive, just swimming, just existing. They retain maybe 10% of the algae's energy. Then the sunfish eat the zooplankton. Same story. Another 90% gone. Then the bass eat the sunfish. Same story again. Each level of the food chain is a tithe, a tax, a toll paid in heat. Lindemann writes this up. He calls it the trophic dynamic aspect of ecology, a title so dry it could soak moisture from the air. But the idea inside it is staggering. Energy flows through ecosystems the way water flows downhill, and at every step, most of it is lost forever, dissipated as the gentle warmth of 10 billion small bodies going about the business of being alive. The paper is rejected. Twice. The reviewers say the data is too limited, the conclusions too sweeping. One reviewer, a respected elder of ecology, writes that Lindemann's ideas are interesting but premature. That word, premature, for a man who has almost no time left. The leading ecologist of the era, a man named G. Evelyn Hutchinson at Yale, who had been Lindemann's mentor, fights for its publication. He writes letters. He argues with editors. He leans on his own reputation, which is considerable, and he does something unusual for the competitive world of academia. He stakes his name on the work of student, because he believes the young man has seen something true, something foundational, something that, once you understand it, you can never unsee. Lindemann dies in June of 1942. He is 27 years old. The paper is published 2 months later, in August, in the journal Ecology. He never sees it in print. Sometimes the most important truths arrive like that, quietly, after the person who found them has already gone. Take a breath. Feel the air going cool and come out warm. That difference, that tiny gap between cool and warm, is the 10% rule working inside you right now. You are converting chemical energy from your last meal into heat and losing most of it to the room around you. Your blanket exists because of thermodynamics. Your need for food exists because of thermodynamics. The reason you ate what you ate today, the specific animal, the specific plant, the specific grain, was determined by a law that a dying man in Wisconsin described while kneeling in the mud of a lake that most people have never heard of. Let that settle for a moment. Outside, whatever sound your night is making, traffic, wind, the hum of a refrigerator, all of it is energy being lost, dissipated. The universe trends toward disorder, toward the even spread of heat, and every living thing on this planet is a brief, beautiful protest against that trend. A temporary organization of matter that captures a sliver of sunlight and, for a little while, holds on. But holding on costs something. It always costs something. The first humans to figure this out, not with equations, not with papers, but with their hands and their hunger, were the ones who survived. They didn't know why it was easier to eat a deer than to eat a wolf. They didn't have a language for trophic levels or energy transfer efficiency, but they had something older than language. They had 10,000 generations of trial and error written into their bones. The ones who chased herbivores lived. The ones who spent their calories chasing predators, burning energy to catch something that had already burned through most of its own energy, starved. Not always, not immediately, but enough. Enough that over deep time, the pattern held. Picture the savannah, not the one from documentaries. Forget the sweeping helicopter shots. Close your eyes and be there. The air is dry and tastes of dust and dried grass. The ground is hard under your bare feet. Cracked clay with tufts of yellow grass sharp enough to cut skin. The sound is insects, a constant, layered drone of crickets and cicadas that rises and falls like breathing. Somewhere to the east, a herd of something is moving. You can't see them yet, but you can feel them through the ground, a faint vibration in the soles of your feet, and you can smell them, the warm, grassy, faintly sour smell of large herbivores. Your body knows what that smell means. It means energy, stored sunlight, concentrated in muscle and fat, packaged in a form your gut can break down and your cells can burn. You're hungry. You're always a little bit hungry. That's the default state of every organism that has ever lived, a low hum of need that never fully quiets. And your hunger has a direction now. It points toward the herd, not toward the lion crouching in the tall grass between you and the herd. You can smell the lion too, if the wind is right. A sharper smell, muskier. Your body knows what that smell means as well, but differently. The lion is not food. The lion is a warning. Not because the lion is stronger than you, though it is, but because the lion is a bad deal. The energy stored in a lion's body costs 10 times what the energy in a gazelle's body cost. The lion ate gazelles to build that muscle. The gazelles ate grass. The grass ate sunlight. By the time that original solar energy has passed through 3 mouths, there's almost nothing left. If you killed a lion and ate it, you'd get a meal. But you'd have spent more calories catching it, more risk, more effort, more time than you'd ever get back. The math is the math. Physics doesn't negotiate. So you go around the lion, you circle wide, staying downwind, and you follow the herd. This is not a choice. Not really. It's gravity. Energy flows downhill, and you follow it. That same gravity is still pulling on you tonight. The meal you ate today, whatever it was, sits at a specific place in the energetic hierarchy of the planet. If you ate rice, you ate stored sunlight, 1 step removed. If you ate chicken, you ate an animal that ate grain that captured sunlight, 2 steps. If you ate tuna, you ate a predator that ate smaller fish, that ate zooplankton, that ate phytoplankton that captured sunlight. 4 steps, maybe 5. And at each step, 90% was lost. The more steps between you and the sun, the more expensive your meal was. Not in money, in photons, in captured starlight, in the fundamental currency of every living thing on this planet. And here's what that means for history, for the story of how you ended up here, in this bed, in this body, listening to this voice. Every civilization that ever rose did so on the back of a plant. Wheat in Mesopotamia, rice in China, maize in Mesoamerica, potatoes in the Andes, taro in Polynesia. Not because those cultures lacked imagination, but because plants are the first rung of the energy ladder. They're the closest you can get to eating sunlight directly. 1 step removed. Maximum efficiency, minimum waste. The cultures that thrived were the ones that found a plant that grew well in their soil and their climate, that stored enough energy in its seeds or tubers to feed a family through winter, and that could be planted and harvested by human hands without exhausting the people doing the planting. That's it. That's the formula. Not divine favor. Not racial superiority, not cultural destiny, just a plant and the math of energy transfer. And when those cultures added animals, when they domesticated cattle, goats, sheep, pigs, they chose, without exception, herbivores, animals that ate grass, that ate grain, that ate the scraps and waste of agriculture. Animals that sat at the second rung of the energy ladder, not the third or fourth. No one domesticated eagles. No one farmed crocodiles. No one built a civilization on the meat of wolves. Because you can't. The 10% rule won't let you. Physics is not interested in your ambitions. The wind picks up outside. Or maybe it doesn't. Maybe your night is perfectly still. Either way, the air around you is full of energy that once was something else. Heat from 1,000 engines, 1,000,000 bodies, 1 billion small metabolic fires burning in the cells of every creature within a mile of where you lie. All of it flowing downhill. All of it following the same rule that Lindemann saw in his lake, that your ancestors felt in their bones, that your dinner plate quietly obeys every single night. The 10% rule. It's in your food. It's in your history. And it's in you. Right now, in the warmth of your own breath against the back of your hand. We're just getting started. There is a freezer in a basement in Woods Hole, Massachusetts. Not a kitchen freezer. An industrial one, the size of a shipping container, humming at -80 degrees Celsius. The air inside, if you opened the door, would burn your lungs before it chilled them. It smells of nothing. Cold, that deep kill smell. Inside that freezer, on metal racks labeled in handwriting, so small you need a magnifying glass, there are thousands of sediment cores. Thin cylinders of mud, sealed in plastic tubes, pulled from the bottoms of lakes and ocean floors all over the world. Each core is a calendar. Each layer, sometimes no thicker than a fingernail, represents a year, or a decade, or a century. Packed into that mud are the chemical signatures of everything that lived and died in the water above. Pick one up, hold in your gloved hands. It's heavier than you'd expect, dense with time. Now slice it. A technician does this with something like a bandsaw, and the smell finally arrives. Wet clay, old iron, a faint sulfurous tang like a match struck hours ago. Under a microscope, each layer reveals its secrets. Pollen grains, perfectly preserved, telling you what plants grew on the surrounding shores. Diatom shells, tiny glass houses built by single-celled algae, telling you the chemistry of the water. And carbon, different isotopes of carbon in different ratios, telling you how much energy flowed through the ecosystem at that moment in time. This is how we read the past, not through books, through mud. The 10% rule, Lindemann's rule, the one he described while dying, didn't stay theoretical for long. Within a decade of his paper's publication, ecologists around the world began testing it. They went to lakes, to forests, to grasslands, to coral reefs. They counted organisms, weighed biomass, measured calories. They tracked how much energy entered a system as sunlight and how much remained at each level of the food chain. The numbers varied. They always do. In some ecosystems, the efficiency at a given trophic level was 5%. In others, 15%. In a few unusual cases, 20%. But the central finding held with a consistency that startled even the skeptics. The vast majority of energy, typically 85 to 95%, was lost at each transfer. Burned, dissipated, radiated away as the gentle, invisible heat of metabolism. Your body is doing this right now. The last meal you ate, whatever it was, whenever it was, your cells are dismantling it, molecule by molecule, cracking open chemical bonds and releasing the energy stored inside. Some of that energy becomes motion, some becomes thought, but most of it, the great majority, becomes heat. You are a radiator, a warm, breathing radiator wrapped in a blanket, losing energy to the room around you with every heartbeat. That's the tax. That's the tithe. Every living thing pays it. In the 1950s, a young ecologist named Howard Odom went to Silver Springs, Florida, a crystal clear river fed by underground aquifers, warm and bright, where you could see straight to the sandy bottom. He spent years there, measuring everything. He measured the sunlight hitting the water surface. He measured the photosynthesis of the aquatic plants. He measured the herbivorous fish, the carnivorous fish, the decomposers in the mud. He built an energy budget for an entire river, line by line, calorie by calorie. The smell of Silver Springs is green, not the color, the smell. That wet, vegetal, slightly sweet scent of submerged plants photosynthesizing in warm water. If you've ever knelt beside a pond in summer and breathed deeply, you know it. Odom knew it the way a carpenter knows the smell of sawdust. He lived in it for years. And what he found confirmed Lindemann's dying work with devastating precision. The plants captured about 1.2% of the incoming solar energy. The herbivores retained about 16% of what the plants had stored. The primary carnivores retained about 11% of the herbivore energy. The top carnivores retained about 5% of that. Step by step, level by level, the energy bled away. Not lost in the strict physics sense. Energy is never lost, only transformed. But lost to the living system, converted from the ordered, usable energy of chemical bonds into the disordered, unusable energy of low-grade heat. Entropy, the universe's patient, gentle victory over every attempt at organization. Where did the lost energy go? Into the water, mostly. Into the warm Florida air drifting over the springs. Into the metabolic hum of millions of fish hearts beating, fish gills pumping, fish muscles twitching through the current. If you could somehow see infrared light, Silver Springs would have glowed, a soft, constant radiance of waste heat pouring off every living thing in the water. A river of light invisible to the eye, but real as stone. Odom drew diagrams, circuit diagrams, like an electrical engineer would draw, because that's what energy flow is fundamentally. A circuit. Sunlight comes in at the top, waste heat goes out at every junction, and what reaches the end is a fraction of a fraction of a fraction of what started. He published his findings in 1957. Unlike Lindemann, he lived to see the impact. His work became a cornerstone, one of the most cited papers in the history of ecology, and it confirmed, with hard numbers from a real ecosystem, what Lindemann had proposed from a muddy lake in the Midwest. The living world runs on a budget, and the budget leaks. Those diagrams changed ecology. They turned a descriptive science into a quantitative one, and they confirmed something that farmers and hunters had always known in their bones. Even without the math, you cannot sustain yourself on the top of the food chain. There isn't enough energy up there. The pyramid narrows as it rises, and at the peak, there's barely enough to keep a single organism alive. I'll pause here. Listen to whatever sound is closest to you. The hum of electronics, maybe. The settling of a building. Your own pulse in your ears if the room is quiet enough. All of those sounds are energy. All of them are bleeding away in entropy, just like the sunlight bleeding through Odom's river. The universe is made of this loss, and so are you. But the evidence doesn't stop at rivers and lakes. In the late 1960s, a different kind of scientist, not an ecologist but a geochemist, began drilling into the ice sheets of Greenland and Antarctica. The cores they pulled up were translucent, blue-white, and when you held one up to the light, you could see individual layers, each one a year of snowfall compressed into ice. Trapped inside those layers were tiny bubbles of ancient atmosphere, air that hadn't been breathed since before the Roman Empire, before the Bronze Age, before agriculture itself. Those bubbles told a story about energy. By measuring the carbon dioxide levels in each layer, scientists could reconstruct the productivity of the planet's ecosystems through time. More CO2 in the atmosphere meant, broadly, less photosynthesis, fewer plants pulling carbon from the air. Less CO2 meant more, and the fluctuations tracked with something else in the ice, dust, tiny mineral grains blown in from distant deserts, settling on the snow and becoming entombed. More dust meant drier conditions, less plant cover, more exposed soil. The base of the energy pyramid, shrinking, in the cold room where these cores are stored. And it is brutally cold, the kind that makes your fingers clumsy and your breath visible as thick clouds. A technician can hold in her hand a slice of ice from 15,000 years ago and read, in the chemistry of those frozen bubbles, the state of the planet's energy budget during the last ice age. The base of the pyramid was narrower then. Less sunlight reached the poles. Less photosynthesis occurred. Less energy entered the living world. And at the top of the pyramid, the megafauna, the mammoths, the cave bears, the saber-toothed cats, were balanced on a razor's edge. Some of them fell off. The 10% rule, working across millennia, helped kill them. Not directly, but by narrowing the base on which they stood. The smell of old ice, if you're curious, is the smell of nothing. Absolute purity, an absence so complete it feels like a presence. Let's build something together. In your mind, picture a pyramid. Not an Egyptian one, though we'll get to those. A simpler one, made of blocks. At the bottom, a vast, wide foundation. Thousands of blocks stretching in every direction, so wide you can't see the edges. Each block is a plant. A blade of grass, a stalk of wheat, a leaf on an oak tree, a strand of kelp drifting in cold ocean water. Each one is doing the same thing, catching light, grabbing photons that traveled 93 million miles from the surface of a star and using them to stitch carbon dioxide and water into sugar. This is photosynthesis, and it is the only door through which energy enters the living world. That's important enough to say again. The only door. Every calorie you have ever consumed, every gram of fat on your body, every twitch of every muscle, every electrical impulse in your brain as you process these words, all of it traces back to a plant, somewhere, catching light. There is no other source, no shortcut, no alternative entrance. Now, on top of that vast green foundation, place a second layer. Smaller, much smaller. These blocks are the herbivores, the grazers, the browsers, the seed eaters, the zooplankton, rabbits and deer and caterpillars and krill. Each one eats the plants below it. But here's where the pyramid starts to betray you. For every 10 blocks on the bottom layer, you can only support one block on the second layer. Because each herbivore burns through 90% of the plant energy it consumes just staying alive, just breathing, just keeping its blood warm, its muscles ready, its neurons firing. 9/10 gone, radiated away as heat. And only 1/10, one lonely block out of 10, gets built into the body of the herbivore, into its muscle, its fat, its bone, into the part that the next level up can actually eat. Now place a third layer, smaller still. These are the primary predators, the foxes, the hawks, the base, the spiders. Each one eats the herbivores below. Same tax, same tithe. For every 10 herbivore blocks, you get one predator block. The pyramid narrows again. And a fourth layer, the top predators, the lions, the orcas, the eagles. For every 10 predator blocks below, one block up here. The apex is tiny, a single point balanced on a mountain of lost energy. This is the pyramid of energy. And unlike a pyramid of stone, you can't cheat it. You can't add blocks at the top without adding exponentially more at the bottom. You can't make the apex wider without making the base impossibly vast. Stay with this image for a moment. Let it build in your mind. The vast green base, shimmering with photosynthesis. The smaller herbivore layer above it, warm-bodied and restless. The narrower predator layer, lean and watchful. And at the very top, a single block. An eagle, a shark, a lion. Magnificent, powerful, and utterly dependent on the immense structure beneath it. Now remove one layer of the base. Take away some of the plants, drought, fire, overgrazing, whatever the cause. Watch what happens. The herbivore layer shrinks. The predator layer shrinks faster. And the apex, the top predator, teeters, falls, goes extinct. This is not a metaphor. This is the actual mechanism behind most mass extinctions. Remove enough of the base, and the pyramid collapses from the top down. The most powerful, most specialized, most energy-expensive organisms die first. Every time. Think about what this means in actual dirt and sunlight. To support 1 kilogram of lion, 1 kilogram of muscle and bone and tawny fur, you need roughly 10 kilograms of zebra. To grow 10 kilograms of zebra, you need roughly 100 kilograms of grass. To grow 100 kilograms of grass, you need a specific amount of soil, water, and sunlight falling on a specific area of land for a specific period of time. 1 kilogram of lion costs 100 kilograms of grass. 1 kilogram of grass costs only sunlight and rain. Now scale that up. Imagine trying to feed a city. Not a modern city, an ancient one. You are in Mesopotamia, Memphis in Egypt, Teotihuacan in the Valley of Mexico. Tens of thousands of people living close together, needing to eat every single day. If everyone in that city ate plants, grain, mostly, you need a certain area of farmland. Call it 1 unit. If everyone in that city ate herbivores, cattle, sheep, you need 10 units of land. Because you need to grow 10 times as much grain to feed the animals that feed the people. And if, in some impossible fever dream, everyone in that city ate predators, lions, wolves, you need 100 units of land, 100 times the original footprint, an area so vast it would swallow the city and everything around it. This is why no civilization on Earth has ever been built on predator meat. Not because of taste, not because of tradition, not because of religion, though religions often encoded the rule into dietary laws without knowing the physics behind it. Because of the pyramid, because the math is merciless. And here's where it touches you directly. The food you ate today sat somewhere on that pyramid. If it was bread or rice or a potato, it sat near the bottom, one step from the sun, cheap in energy, efficient to produce. If it was chicken or pork, it sat one level higher, 2 steps from the sun, 10 times more expensive in captured sunlight. If it was beef, it sat higher still, because cattle are less efficient converters than poultry. And if it was tuna, wild-caught, open ocean tuna, it sat near the top. Tuna eat mackerel. Mackerel eat anchovies. Anchovies eat copepods. Copepods eat phytoplankton. Phytoplankton eat light. 5 levels. 5 tides. 5 rounds of 90% loss. Your tuna sandwich, in terms of the original solar energy required to produce it, cost roughly 100,000 times more than a slice of bread. The pyramid doesn't care about your grocery bill. It cares about photons. And this is where the pyramid stops being abstract and starts being something you can feel in your hands. Archaeologists have measured it at the ruins of ancient grain stores in Egypt, in Mesopotamia, in the Indus Valley. They've calculated how much wheat or barley a city needed to store to survive a single year. The numbers are staggering. The granaries of a modest Sumerian city-state held enough grain to fill modern freight trains stretching for miles. All of it sitting at the bottom of the pyramid. All of it one step from the sun. And when those cities kept livestock, when they penned cattle or fattened geese, the records show the cost. Cuneiform tablets from UR, for 1,000 years old, list the grain rations allocated to temple cattle. The amounts are enormous. 10, sometimes 15 times more grain going into the animals than meat coming out. The ancient accountants didn't know about trophic levels, but they could count, and the numbers told the same story that Lindemann would tell 4,000 years later. The pyramid is the pyramid. It doesn't change because you write the numbers in cuneiform instead of decimals. Let that number sit with you for a moment. Feel the weight of it. 100,000 to 1. And somewhere in your body, in the cells that are digesting tonight's meal, that ratio is playing out in miniature. Energy being burned, heat being lost, the pyramid doing its patient, silent work. The rain on the window, or the silence, whichever your night has given you. Let it hold you here for a moment before we go further. Now, here's where it gets complicated. Because the 10% rule is a beautiful idea, and beautiful ideas in science have a way of being almost true, which is both their power and their danger. The first crack appeared in the oceans. In the 1970s and 1980s, marine ecologists began measuring energy transfer in open ocean ecosystems. The deep blue water far from shore, where the food chain starts with phytoplankton, so small you could fit 100 of them on the period at the end of sentence. And they found something unexpected. The transfer efficiencies between trophic levels in the open ocean were often higher than 10%. Sometimes 15%, sometimes 20%, in certain cold, nutrient-rich waters, the kind that smell of salt and iron when the wind blows off them. The efficiency climbed even higher. Why? Cold-blooded animals. That's part of the answer. Fish don't waste energy keeping themselves warm the way mammals and birds do. A trout in a cold stream doesn't need to maintain 37 degrees Celsius. Its body temperature matches the water around it, and that saves enormous amounts of energy. Energy that would otherwise be radiated away, as heat is instead available to be stored in the fish's tissues, making it a more efficient package of calories for whatever eats it next. This matters. This matters enormously, and not just for marine biology. It means the 10% rule isn't really a fixed law. It's an average, a rough guideline, a central tendency around which real ecosystems scatter like beads rolling on a tilted table. Some ecologists began pushing back. The rule was too simple, they said, too clean. It smoothed over the messy reality of actual living systems, where a bear might eat berries one day and salmon the next, shifting between trophic levels like a diner moving between courses, where a fungus might decompose a fallen tree and recycle nutrients back into the soil, creating loops and shortcuts in the energy flow that Lindemann's neat diagrams couldn't capture. They weren't wrong. The real world is always messier than the model. In the 1990s, new tools arrived. Stable isotope analysis, a technique where scientists measure the ratio of different forms of nitrogen and carbon in an organism's tissues to determine what it actually ate, not what we assumed it ate. The chemistry is subtle. Nitrogen, 15 accumulates as you move up the food chain, enriching at each trophic level by about 3.4 parts per thousand. By measuring the nitrogen isotope ratio in a bone fragment, a feather, a strand of hair, a scientist can place that organism on the energy pyramid with surprising precision. Imagine holding a fragment of bone from an animal that died 3,000 years ago. It's lighter than you'd expect, dry, porous, the color of old parchment. It smells faintly of chalk. You scrape a few milligrams of powder from its surface, dissolve it in acid, feed it into a mass spectrometer, a machine that hums at a frequency you can feel in your chest more than hear with your ears. And the machine tells you what this animal ate. Not in general terms, in specific isotopic ratios that place it precisely on the pyramid. Those ratios revealed surprises. Ancient humans, it turned out, were often eating higher on the food chain than expected. Coastal populations in particular showed isotopic signatures that rivaled marine predators. They were eating fish that ate zooplankton, climbing 3 or 4 trophic levels routinely. And they were doing it successfully, sustainably for thousands of years. The bones don't lie. Neither does the collagen preserved inside them, where the nitrogen isotopes sit like receipts for meals eaten millennia ago. Even more surprising were the inland findings. Populations along major rivers, the Columbia, the Rhine, the Danube, the Nile, showed elevated trophic signatures too. Salmon, sturgeon, catfish. These are predatory fish, sitting 2 or 3 levels above the phytoplankton. And ancient people were eating them in quantities large enough to shift the isotopic profile of their entire skeleton. A researcher at the Max Planck Institute, working in a lab that smells of distilled water and the faint ozone tang of mass spectrometers running hot, published a study in 2004 showing that some Neanderthal populations had trophic positions equivalent to wolves. They were apex predators, top of the food chain, and they persisted for hundreds of thousands of years. How? If the 10% rule is iron, how did these people afford to eat so high on the pyramid? The answer lives in the ocean's geometry. Coastal upwelling zones, places where deep, cold, nutrient-rich water rises to the surface, are among the most productive ecosystems on the planet. The sheer volume of photosynthesis happening in those waters is staggering. The base of the pyramid is so astronomically wide that even after 4 or 5 rounds of 90% loss, there's still enough energy at the top to support a human population. Think of it this way. If the base of the pyramid in a dry grassland is a dinner table, the base of the pyramid in a coastal upwelling zone is a football field. You can afford to lose 90% 4 times over when you start with a football field's worth of energy. The percentage taken at each step remains the same, but the starting amount is so vast that the remnant, the slim 10% of the 10% of the 10%, is still more food than a human community needs. This is why the richest fisheries in the world sit along the coasts of Peru, Namibia, California, and Norway, places where cold, deep water wells up and feeds enormous blooms of phytoplankton. The base of the pyramid in those waters is wider than almost anywhere on land. And the humans who settled those coasts thousands of years ago found themselves standing atop a food chain that could support them even at high trophic levels. The rule wasn't broken. The base was just bigger than anyone had imagined. And this is where the debate stands today, in the quiet offices and labs where ecologists still argue about Lindemann's legacy. The 10% figure is not a law in the way that gravity is a law. It's a central tendency, a median. In endothermic systems, warm-blooded food chains on land, it holds remarkably well. In ectothermic systems, cold-blooded food chains in water, the efficiency can be higher, sometimes much higher. And in detrital food webs, where energy enters not through photosynthesis but through decomposition, the whole model gets complicated in ways that are still being untangled. Some modern ecologists prefer to talk about ecological efficiency as a range, 5 to 20%, depending on the system. Others argue that the trophic level concept itself is flawed, that real ecosystems are tangled webs, not neat pyramids, and that trying to assign a single number to a single level is like trying to assign a single temperature to a bonfire. The average might be meaningful, but it hides enormous variation. There are the omnivory people who point out that most animals, including humans, don't eat at a single trophic level at all. We eat salads and steaks, sometimes in the same meal. We are trophic level 2.2 on a Tuesday and trophic level 3.8 on a Friday. The neat pyramid dissolves into a web, and the web dissolves into a cloud of shifting, overlapping, context-dependent feeding relationships that resist simple quantification. There are the microbial ecologists, who argue that the entire trophic framework ignores the largest biomass on the planet. The bacteria, the archaea, the fungi, which don't fit neatly into any level. They decompose, they recycle, they form symbiotic relationships with plants and animals that short-circuit the energy chain in ways Lindemann never imagined. The mycorrhizal networks beneath a forest floor, fungal filaments connecting tree roots in an underground web sometimes called the Wood Wide Web, transfer nutrients and even energy between organisms in patterns that look nothing like a pyramid. And there are the complexity theorists who see the food web as a complex adaptive system, like a stock market or a weather pattern, where small changes can cascade unpredictably and where the average behavior of the whole tells you very little about the behavior of any individual part. All of these critiques have merit. None of them are trivial. And yet the central insight survives. Energy is lost at every transfer. The loss is substantial, and the consequences for population sizes, for ecosystem structure, for the shape of human civilization itself, are profound. You could debate the percentage. You can argue about whether it's 8% or 12% or 17% in a specific lake in a specific year. But you cannot argue with the direction. Energy flows from producers to consumers, and at every step, most of it vanishes into heat. The pyramid narrows. The top is always smaller than the bottom, and any organism, including you, that tries to live at the top of a long food chain is playing a game with very thin margins. This is what Lindemann saw, not the specific number, the shape, the direction, the inevitability of loss. He saw it in the mud of a lake in Wisconsin, and he was right. And the fact that the rule bends doesn't mean it breaks. A river bends too. it still flows downhill. The question that carries us forward is this: if the rules shaped which animals we eat and which plants we grow, did it also shape how we live? Did the 10% rule determine the size of our cities, the density of our populations, the rhythm of our wars? Did thermodynamics write our history? Hold that question. Let it sit in the dark with you like a coal cooling slowly in an old hearth. We'll come back to it. For now, breathe. Feel the warmth under your blanket, your own metabolic heat, your own small protest against entropy. The room is quiet, or near enough. The day is done, and the story, like the energy flowing through Lindemann's lake, moves on. It is roughly 9,000 years ago. The place is the floodplain of the Euphrates, in what will one day be called southern Iraq, but is now just land, flat, warm, threaded with slow brown water. There is no Iraq. There is no name for this place that anyone outside of it would recognize. There is just the river, and the mud, and the sky. A woman wakes up. She doesn't open her eyes right away. She lies still and listens, the way you sometimes do in the first seconds of waking, when the world is just sound. The river is there, not loud, not rushing, but present. A low, continuous murmur, like someone humming in another room. Insects already, the dry rattle of something in the reeds. A frog, perhaps, or a water bird shifting in its roost. And birds, dozens of species she has no names for, but knows by voice the way you know the voices of your family. The one that sounds like two stones clicking together. The one that sounds like a question repeated over and over. The one that sounds like water being poured from a height. Beneath the birdsong, something subtler. The settlement itself. The small sounds of other people stirring in other shelters. A cough. The rustle of reed mats. A child murmuring in the last fragments of a dream. The community waking like a single organism, cell by cell. The air smells of mud, not the sharp, clean mud of a mountain stream. This is ancient river mud, thick and organic, rich with the smell of decomposition and growth tangled together so tightly they become the same thing. It smells like fertility, like the earth digesting itself and becoming new. If you've ever held a handful of wet compost close to your face and breathe in, you're close, but warmer. Everything here is warmer. There's also ash, the ghost of last night's fire, gray and fine, mixing with the morning dew on every surface, and underneath everything. So constant she no longer consciously notices it, the smell of the river itself, mineral, vegetal, ancient. She sits up. The mat beneath her is woven reed, stiff, slightly damp from the humidity of the night, pressing its pattern into the skin of her back and shoulders. She can feel the impressions with her fingertips. The floor of the shelter is packed earth, cool against her bare feet as she stands. The walls are bundled reeds, lashed together and plastered with river mud that has dried to a pale gray-brown. When the wind blows, the walls creak softly, and fine dust sifts down from the seams. She is hungry. This is the fact that matters. This is the fact that will shape every hour of her day, every decision her community makes, every structure they build, every child they can afford to feed. She is hungry, and the energy to satisfy that hunger must come from somewhere. It must be captured, processed, stored, and consumed. And at every step, most of it will be lost. She doesn't know the word trophic. She doesn't know the word thermodynamics. But she knows in her muscles, in her gut, in the calculations her brain runs without conscious thought, exactly where the energy is. She knows it the way a compass knows north. The grain stores are nearby. She can smell them too, if the wind is right. A dry, slightly sweet, slightly dusty smell. Barley mostly. Some emmer wheat. It sits in large clay-lined pits, sealed with mud plaster to keep out the rats and the damp. Those pits represent stored sunlight. Months of photosynthesis, concentrated into hard little kernels that will keep through the dry season if the seals hold. This is the revolution, not a dramatic one. No flags, no speeches, no single moment of invention. Just this. Someone, generations before this woman was born, figured out that you could take seeds from wild grasses, plant them in the wet mud left behind by the river's annual flood, and harvest more than you planted. You could store the surplus. You could eat it later. You could feed more people than the land would otherwise support. You could cheat the pyramid, not by breaking the 10% rule. That's impossible, but by shortening the chain, by cutting out the middle levels, by eating the plants directly instead of waiting for an animal to eat them first and losing 90% in the transaction. That's what agriculture is at its energetic core. It's not a lifestyle choice. It's not a cultural preference. It's a thermodynamic shortcut. One step from the sun instead of 2 or 3. Maximum energy retained. Minimum waste heat. Your body understands this. Right now, lying wherever you are, your digestive system is built to handle exactly this kind of food. Starchy seeds, ground and cooked. Your molars are flat for grinding grain. Your saliva contains amylase, an enzyme specifically designed to break down starch into sugar. You carry more copies of the amylase gene than your primate cousins do. A mutation that spread through human populations precisely because it made grain digestion more efficient. Your DNA has been edited by the 10% rule. The pyramid is written into your mouth. The morning light is arriving now in the story, not the sharp white light of noon, the soft amber light of early day, when the sun is still low and the shadows are long and everything looks slightly golden. The woman walks to the grain pit. She kneels. She breaks the mud seal with her hands. Her fingers are strong, the nails short and cracked, the knuckles calloused from years of grinding and weaving and digging. The barley inside is cool and dry. She scoops out a portion, enough for the morning meal, and carries it in a shallow basket to the grinding stone. The grinding stone is basalt, heavy, dark, rough-surfaced. It sits in a shallow depression in the earth, worn smooth at the center from years of use. She kneels before it and begins to grind. The sound is distinctive, a low, rhythmic rasp, stone against grain, like a heartbeat made of friction. If you've ever heard a mortar and pestle working slowly, you're close. But deeper, more resonant, the kind of sound that carries through the morning air and tells everyone in the settlement that the day has begun. Back and forth, back and forth. Her shoulders roll with emotion. Her breath finds the rhythm. The barley gives up its structure, kernel by kernel, and becomes flour, coarse, pale, flecked with bran. The smell intensifies. Raw grain has a grassy, slightly sweet scent. But when it's crushed, it releases something sharper, almost nutty. The volatile compounds trapped inside the seed coat escape into the air, and for a moment, the space around the grinding stone smells like bread that hasn't been baked yet. She is converting energy. That's what this is. She is taking stored solar energy, photons captured by barley plants months ago, locked into starch molecules, sealed inside seed coats, and she is breaking it down into a form her body can use. The grinding doesn't add energy. It just makes the energy accessible. It cracks open the package, and the cost of this conversion is almost nothing. A few hundred calories of her own muscular effort to process a few thousand calories of grain. The return is enormous. Positive. Sustainable. This is why her people are here, in this place, doing this work. Because the math works. Because the first rung of the pyramid gives back more than it takes. The fire is lit. Someone else has done this. An older man, perhaps, or a child old enough to be trusted with coals. The smoke rises thin and blue in the still morning air, carrying the smell of dried reed and cattle dung, the fuel they use when wood is scarce, which is most of the time on this treeless floodplain. The flatbread goes onto a heated stone near the fire. It blisters, darkens, fills the air with the smell of toasted grain. The Maillard reaction, the chemical browning of sugars and amino acids under heat, produces hundreds of aromatic compounds. Your brain is wired to find this smell irresistible. 9,000 years later, the smell of baking bread still stops you in the street. Breakfast is ready. The woman eats. Her children eat. The settlement eats. One step from the sun, 90% retained. The pyramid, for this brief moment, is as generous as it will ever be. But grain alone is not enough. The body needs fat. It needs protein. It needs the micronutrients that plants provide in small doses, but animal tissues provide in concentrated abundance. Iron, zinc, vitamin B12, the long-chain fatty acids that build brain tissue. The woman knows none of these words, but her cravings know. The body asks for what it needs in the only language it has. Hunger that is specific, directional, pointed at something. Today, that something is milk. Outside the settlement, in a pen made of bundled reeds and dried mud, there are cattle. Not many, maybe a dozen. They are smaller than the cattle you'd recognize today, ringier, with longer horns and rougher coats. They smell powerfully, a dense, warm, animal smell, part grass and part fermentation. The smell of large herbivore gut bacteria doing their ancient work of breaking down cellulose. If you've ever stood downwind of a dairy farm, you know a version of this smell, but rawer, less sanitized. The smell of animals who sleep in their own warmth, and whose dung dries in the sun where it falls. These cattle are expensive, not in money. There is no money yet. Expensive in energy. Every day they eat. They eat the grasses and reeds that grow along the river margins. They eat the stubble left in the fields after harvest. They eat the chaff and bran that the grinding process leaves behind. And of everything they eat, they keep only about 10%. The rest, the vast majority, they burn. They burn at keeping their massive bodies warm through the cool desert nights. They burn at walking to water and back. They burn at digesting, metabolizing, existing. A cow is a furnace, a beautiful, lowing, slow-blinking furnace that converts 10 units of plant energy into 1 unit of meat, milk, and bone. The woman knows this intuitively. She knows that the cattle eat more than they give back. She knows that feeding cattle means growing more grain, or finding more pasture, or both. She knows that every animal in that pen is a mouth that competes with human mouths for the same base of stored sunlight. But she keeps them anyway, because the milk is worth it. She approaches the pen. One of the cows, a reddish-brown female with a calf at her side, stands patiently as the woman crouches beside her. The udder is warm, almost hot, against her hands. The teats are rough-skinned and slightly damp. The first streams of milk hit the clay bowl with a thin, high sound, a ringing that deepens as the bowl fills. The milk is warm, rich, faintly sweet, with a grassy undertone that reflects the animal's diet. It foams slightly at the surface. The fat globules are large, visible. This is not the homogenized, processed milk of a modern supermarket. This is raw energy, dense and white and alive with bacteria. She is paying the 10% tax. She knows it. The milk she collects is only a fraction of the energy the cow consumed. But the milk contains things that grain doesn't: complete proteins, saturated fats, calcium, phosphorus. Things her children need to grow bones and build brains. Things the pyramid charges a premium for because they come from the second rung, not the first. This is the bargain. This is the deal that every agricultural society in history has struck with the 10% rule. Eat plants for energy, keep animals for nutrition. Use the base of the pyramid for calories. Use the second level, sparingly, carefully, at great cost, for the nutrients that plants alone can't provide in sufficient quantities. The cattle serve other purposes too. Their dung, dried in flat cakes on the walls of the shelter, is fuel for the fire. Their hides, scraped and stretched and dried, become leather for sandals, for bags, for the covers of shelters. Their bones become tools, awls, needles, scrapers. Their sinews become thread. Nothing is wasted, because nothing can be afforded to be wasted. The energy budget is too tight. And there is something else the cattle provide. Something harder to quantify, but no less real. They provide security, stored wealth, a buffer against the drought that will come. Not might come, will come, because droughts always come in this landscape, every few years, as reliable as the seasons. When the barley fails, when the grain pit's empty, the cattle can be slaughtered. Their bodies contain weeks of concentrated energy, energy that was stored as fat and muscle during the good times, energy that could be released in the bad times. They are living batteries, biological savings accounts that walk on 4 legs and reproduce themselves. This is the deep logic of animal domestication. Not companionship, not culture, thermodynamics. The animals are energy storage devices, positioned on the second rung of the pyramid, expensive to maintain, but invaluable as insurance. There is a tenderness in it, too, though. Don't miss that. The woman who milks the cow in the morning, she knows this animal. She knows the particular way this cow shifts her weight from one hind leg to the other when she's uncomfortable. She knows the texture of this cow's hide, the pattern of whorls in the fur behind her ears. She talks to the cow as she milks, softly, in sounds that aren't quite words, just tones, reassurances, the murmured nothing sounds that humans make to calm animals, and, in the making, calm themselves. The relationship is economic, but it is also something else, something that sits outside the pyramid's cold accounting. Call a bond, call it mutual dependence, call it the earliest draft of what we now call animal husbandry, a phrase that contains the word husband for a reason. To husband something is to tend it, to care for it, to manage it with attention and responsibility. It is an act of maintenance, of keeping something alive so that it can keep you alive in return. Your ancestors understood this, not with equations, with their hands and their hunger and the hard experience of watching children starve when the rains didn't come. The morning continues. The children play in the dust near the grain stores, their bare feet leaving small prints in the packed earth. An older child is learning to shape clay, pressing a lump of wet river clay into a rough bowl, smoothing the walls with wet fingers, setting it near the fire to dry. The clay is cool and heavy and smells of the river. The child's concentration is total, the tongue slightly protruding from the corner of the mouth. A gesture so human, so universal, that you'd recognize it in any century, in any culture, in any child absorbed in the work of making something with their hands. A woman is weaving a reed mat, her fingers moving in patterns so practiced they no longer require thought. The reeds are flexible when fresh, stiff when dry, and they make a soft creaking sound as they bend and interlock. The finished mat will be a floor covering, a sleeping surface, a screen against the wind. It costs almost no energy to make, just the labor of hands and the patience of hours. An old man sits in the shade of a reed wall and tells a story to no one in particular, or maybe to everyone within earshot. His voice is low and rhythmic, rising and falling in patterns that might be the ancestor's song. You can't hear the words. They're in a language that no living person speaks, a language that left no written record, a language that existed only in the breath of people who have been gone for 9,000 years. But the rhythm you'd recognize, because it's the same rhythm your grandmother used when she told you stories, or your father used when he read to you at bedtime, or that voice in your earbuds is using right now. The rise and fall, the pause before the important part, the drop in pitch that means something serious is coming. The human voice has been doing this for 100,000 years, and your brain is tuned to it like a radio to a frequency. These people are not primitive. Say that quietly to yourself. These people are not primitive. They are you in different clothes, in a different landscape, solving the same problems you solve. How to eat, how to stay warm, how to raise children, how to make sense of a world that doesn't explain itself. They carry the same genes. Their hearts beat at the same rate. Their children laugh at the same pitch. The only difference is the pyramid. The energy pyramid they're standing on is shorter, narrower, more precarious. One bad season, one fail harvest, one disease that sweeps through the cattle pen, and the math collapses. They know this. They carry this knowledge the way you carry your phone, always present, always at the edge of awareness, never fully set down. The morning passes, the sun climbs, the air gets heavy with heat. Something is about to change. The first sign is the wind. It shifts, not dramatically, not a storm, not a gust, just a change in direction from the river-cooled south to the dry north, and with it, a change in smell. The wet green scent of the floodplain gives way to something drier, dustier, faintly mineral. The smell of empty land. The smell of soil that has forgotten rain. The woman notices. You notice the wind when your life depends on what grows in the ground. She looks north, though there's nothing to see. The horizon is flat, featureless, a line of beige and pale blue. But the wind is talking, and she's listening. The rains are late. Not gone. Not yet. Just late. The river is lower than it should be at this point in the season. The mud at its edges is cracking into polygons. That specific geometric pattern that dry mud makes. Each piece curling slightly at the edges, separating from its neighbors. She knows this pattern. She's seen it before. It means the water table is dropping. It means the roots of the barley plants are reaching down and finding less. The barley itself tells the story. The stalks are shorter this season. The heads are lighter. She can feel the difference when she runs her fingers through the grain. The kernels are smaller, harder, less plump. Each one contains fewer calories. The base of the pyramid is shrinking. Feel that. Let that settle into your body, because this is not ancient history. This is the architecture of anxiety. That tightening in the chest, that quiet dread that something you depend on is becoming less reliable. You know this feeling. You feel it when rent goes up, or when layoffs are announced, or when the news talks about supply chains. The modern words are different. The sensation in the body is identical. Your nervous system was built for this exact moment. The moment when the base narrows and the math starts to close in. The cattle are restless. They've been grazing further from the settlement, walking longer distances to find enough to eat. The grasses along the river margins are thinning. The ground between the clumps is bare and hard. The cattle return in the evenings with their flanks slightly hollowed, their ribs a little more visible beneath the dusty hide. They eat more and gain less. The 10% rule is still operating, but the 100% they start with is shrinking, which means the 10% they pass on to the humans is shrinking too. The math is tightening. It's not a crisis yet, but it's a trend. And trends, in a system with no surplus, become crises with terrifying speed. The old man who tells stories, he remembers. He remembers a drought when he was young, perhaps 30 years ago. He remembers the grain pits emptying. He remembers the cattle dying, not all at once, but one by one, their bodies growing thin, their eyes growing dull, until they lay down in the dust and didn't get up. He remembers the smell of that, the sweet, cloying, terrible smell of a large animal decomposing in dry heat. It stays in the nostrils for days, for years, if you were a child when you smelled it. He remembers people leaving, families packing what they could carry and walking south, toward the river's deeper channels, toward the marshes where there was always something to eat. Fish, waterfowl, turtles, the starchy tubers of aquatic plants. Not abundant, not comfortable, but alive. He remembers this because his job is to remember. In a world without writing, without records, without archives, the old man's memory is the library. The history of the community lives in his voice, in the stories he tells, in the rhythms and repetitions that help the words survive across generations. He is a living book, and what he's written on his pages is the record of the pyramid's failures. The woman listens. She has heard this story before, many times, in slightly different versions. the details shifting with each telling the way details do when they pass through human memory. But the core is always the same. The rain stopped. The grain failed. The cattle died. The people moved. And the reason is always the same, though they don't have the language for it. The base of the pyramid narrowed, and everything above it fell. She makes decisions now. Quiet decisions, unannounced, the kind that women in subsistence communities have been making for 10,000 years without anyone recording them in histories or epics. She reduces the grain ration, not dramatically, not enough to cause alarm, but enough. A slightly smaller handful into the grinding stone each morning. A slightly thinner flatbread. The children won't notice. The adults will, but they'll understand. She instructs the herder, her brother, perhaps, or her eldest son, to move the cattle further east, toward a tributary where the grasses might still be green. This is a risk. Further from the settlement means further from protection, from water, from the social web that holds everything together. But the cattle need to eat. The second rung of the pyramid has to be maintained, because without it, there's no milk, no emergency meat, no buffer against the worst-case scenario. She checks the grain pits, opens each seal, reaches inside, feels the level with her hand. The barley is cool and dry. That's good. No mold, no insects. But the levels are lower than they should be. There's enough for perhaps 2 months, maybe 3, with the reduced rations. After that, the pits will be empty, and the community will be standing on the first rung of the pyramid with nothing beneath them. This is the edge, the thin, precarious edge where the 10% rule becomes a matter of life and death, where the abstract physics of energy transfer translates into a mother's hand measuring grain in the half-light of dawn, calculating without numbers, budgeting without ledgers, solving an equation she doesn't know she's solving. The wind blows from the north again, dry, warm, empty, and somewhere far to the north, beyond the horizon, beyond the edge of anything this woman has ever seen or imagined, the climate system is shifting. Ice cores from Greenland will one day record this moment. A flicker in the oxygen isotope ratios, a brief dip in the methane concentrations, a signature of drying air and retreating monsoons. The 8.2 kilo-year event, climatologists will call it. A sudden pulse of cold fresh water into the North Atlantic from the collapsing remnants of a glacial lake, disrupting ocean circulation, shifting rainfall patterns across the entire northern hemisphere. She doesn't know any of this. She knows the wind. She knows the grain. She knows the sound of her children breathing in their sleep and the weight of the decisions she carries. The drought will last, not forever, but long enough. Long enough for the settlement to empty. Long enough for the grain pits to echo when you tap their walls. Long enough for the cattle to die, one by one, in the dust, their bodies feeding the vultures and the jackals, predators and scavengers who sit high on the pyramid and who thrive, briefly, on the collapse of the levels below. Some of the people will move south, to the marshes, just as the old man's stories predicted. Some will move east, following the rivers deeper into the alluvial plain, looking for land where the water still reaches. Some will not make it, but enough will. Enough always do. That's the other side of the story. The side will come to later. For now, just hold this. The pyramid wobbled. The base shrank, and the people at the top did what people at the top of any energy system do when the foundation contracts. They adapted, they moved, they survived, or they didn't, and someone else did, and the story continued through them. The wind dies down, the evening comes, the stars appear, thick and bright in a sky unmarked by artificial light. A sky you would not believe if you saw it from where you're lying now. The Milky Way is not a faint smear here. It's a river of light, dense enough to cast shadows, close enough to touch if you could just reach a little higher. The fire crackles. The children sleep. The woman sits in the dark and listens to the night sounds. The river, the insects, the soft movements of cattle settling in their pen. Her hand rests on the ground beside her, fingers curled into the dry earth. The same earth you're resting on right now. Different continent, different millennium. Same planet. Same thin layer of soil and water and atmosphere. Catching the same star's light. Running the same calculations of energy and loss. The same pyramid. Holding all of us. Holding you. Rest here for a moment. We'll go on when you're ready. Now come back. Come back to your body, to your bed, to the sound of whatever your night sounds like. Come back to the hum of electricity in the walls, the distant drone of a highway, or an air conditioner, or the nothing sound of a quiet suburb after midnight. Come back to the weight of your blanket, the pillow against your ear, the faint glow of a screen somewhere in the room. You are 9,000 years away from that woman on the Euphrates. You are also 0 years away, because the system she lived inside, the pyramid, the energy flow, the 10% rule, is still running. It never stopped. It just got dressed up in different clothes. Here's the modern version. Right now, roughly 40% of the Earth's ice-free land surface is used for agriculture. Not 4%, not 14%, 40%. Almost half the habitable land on the planet is dedicated to one single task: capturing solar energy through photosynthesis and converting it into food for human beings. And of that 40%, the vast majority, nearly 80%, is used not to grow plants for people to eat, but to grow plants for animals to eat. Pasture land, feed crops, soy and corn and alfalfa and barley, planted in vast monocultures stretching to the horizon, harvested by machines that burn fossil fuels, trucked to feedlots where cattle and pigs and chickens consume it and convert it, with the same brutal inefficiency that Lindemann measured in his lake, into meat. The 10% rule, operating at industrial scale. The numbers are staggering when you lay them out. A single kilogram of beef requires, on average, roughly 25 kilograms of grain and approximately 15,000 liters of water to produce. A kilogram of chicken is cheaper, about 3.3 kilograms of grain, roughly 4,300 liters of water. A kilogram of lentils needs almost no grain input at all, just soil and rain and sunlight, and about 1,250 liters of water. The pyramid hasn't changed. We just scaled it up to a size that would stagger the woman grinding barley by the river. And here's the echo that should stop you. The thing that connects her world to yours with a line as straight as a plum drop. She watched her grain pits empty. She watched the base of the pyramid shrink as the rains failed and the climate shifted. She made quiet calculations with her hands, reducing rations, stretching stores, moving cattle to distant pastures. We're doing the same thing. The language is different. We say supply chain disruption. and drought-driven crop failure and commodity price volatility. She said nothing. She just felt the grain level in the pit getting lower under her fingers. But the underlying event is identical. The base of the energy pyramid is under pressure. The same base, the same sun, the same photosynthetic capture of light and conversion to sugar that has underwritten every human meal since the first. Global crop yields are plateauing. After decades of steady increase, the so-called Green Revolution, which was really an energy revolution, powered by fossil fuels converted into fertilizer, irrigation, and mechanized harvesting. The growth curve is flattening. Wheat yields in Western Europe have been essentially flat since the mid-2000s. Rice yields in East Asia are approaching their theoretical biological ceiling. The low-hanging fruit of agricultural intensification has been picked. Meanwhile, the demand curve keeps climbing. 8 billion mouths, 9 billion by mid-century, each one requiring roughly 2,000 to 2,500 kilocalories per day, a number that hasn't changed since the Euphrates. The human body is the same furnace it's always been. It doesn't care about technology. It cares about photons and the climate. The same climate system that sent the 8.2 kilo-year pulse of cold water into the North Atlantic and dried out the Euphrates floodplain is shifting again. You know this. You don't need me to tell you. You can feel in the summers that arrive earlier and stay later, in the rain that comes in bursts instead of steady rhythms, in the news reports about heat waves and failed harvests and rivers running low. The woman felt the wind shift from south to north. You feel the same shift in different ways. In the price of eggs, in the news from farms you'll never visit, in a vague, ambient anxiety about the future that sits in your chest like a stone you can't quite swallow. The pyramid is wobbling. The base is under stress. And everything above it, everything including you, feels the tremor. Listen to the quiet for a moment. Whatever is outside your window, wind, rain, traffic, nothing at all, hold it. Let it be the space between two worlds, the ancient and the modern, the floodplain and the supermarket, the woman with her hand in the grain pit and you with your hand on your phone, scrolling past headlines about food prices and water shortages and record temperatures. The parallels are not poetic. They are structural. The same physics, the same pyramid, the same 10% rule taxing every transfer of energy from sun to mouth. The woman solved it locally, reduced rations, moved the cattle, watched the grain. We solve it globally. Fertilizer subsidies, international grain markets, genetically modified drought-resistant crops. But the underlying problem is unchanged. There's a finite amount of energy entering the living world through photosynthesis, and there are a growing number of warm-blooded organisms trying to live on it. And here's the detail that would have made Lindemann's head spin if he'd lived to see it. The modern global food system, the one that feeds 8 billion people, runs on two pyramids, not one. The first is the ancient one, sunlight to plants to animals to humans. The second is new, barely a century old. Fossilized sunlight, coal, oil, natural gas, pumped from the earth and converted into fertilizer, into fuel for tractors and ships, into the electricity that powers cold storage and processing plants. We are eating the past, burning ancient photosynthesis, sunlight captured by plants millions of years ago, compressed into hydrocarbons by geological time to subsidize the present pyramid. Every calorie of food that reaches your plate required, on average, roughly 7 to 10 calories of fossil fuel energy to produce, process, and transport. The modern food system doesn't run on the sun alone. It runs on the sun plus the ghosts of ancient suns, dug from the earth and burned. The woman on the Euphrates had one pyramid. We have two, stacked on top of each other, and the lower one, the fossil fuel one, is finite. It is running down, and when it narrows, the upper pyramid, the one that actually feeds us, will feel the squeeze. This is not a lecture. This is a mirror. The woman by the river and you in your bed are looking at each other across 9,000 years, and you're solving the same problem, the same equation, the same physics. The difference is scale. Her crisis was local. One floodplain, one community, a few hundred people. Your crisis is global. The base of the pyramid now stretches across every continent, and the pressures on it, climate change, soil depletion, water scarcity, the sheer metabolic demand of 8 billion warm-blooded humans and the 70 billion livestock animals we maintain to feed them, are planetary in scope. But the math is the same. The math is always the same. Let that sit. Let the room hold it for you. The hum of the refrigerator, which is itself a device that slows the decay of stored food energy, a technological extension of the grain pit, keeps its steady tone. The night continues. You are warm. You are fed. The pyramid, for now, is holding. There's something else the pyramid explains. Something closer. Something you carry in your body right now. In the specific architecture of your cravings and your anxieties and the way your brain responds to food. You are mismatched. That's not an insult. It's a diagnosis. And it's one of the most important ideas in modern biology. The concept of evolutionary mismatch. The recognition that your body and brain were built for a world that no longer exists. Think about sugar. Right now, somewhere in your kitchen or your memory, there's something sweet. Chocolate, fruit, a soft drink, ice cream, the remains of dessert. In some part of your brain, a deep, old part buried beneath the cortex, beneath conscious thought, beneath everything you think of as you, wants it. Not casually, urgently, the way a compass needle wants north. That craving is ancient. It was written into your neural circuitry at a time when sugar was rare, seasonal, and always attached to something nutritious. A ripe fruit, honey guarded by stinging insects. The sweet, starchy heart of a root vegetable dug from hard ground with bleeding fingers. In the world your brain was built for, the world of the Euphrates, and before that, the savanna, and before that, the forest canopy, sweetness was a reliable signal. It meant energy, concentrated, fast-acting energy from the base of the pyramid, packaged in a form that could be eaten immediately and stored as fat for the lean times that were always coming. Your brain learned to crave sugar the way it learned to crave oxygen, as a survival mechanism, as a non-negotiable directive from the deepest layers of your operating system. But the world changed. The signal didn't. Now sugar is everywhere. It's in your bread. It's in your pasta sauce. It's in the flavored yogurt and the granola bars and the salad dressing. It's been extracted, refined, concentrated, and inserted into nearly every processed food on the supermarket shelf. isolated from the fiber and nutrients that originally accompanied it, stripped of every context that made the craving appropriate, and delivered in doses that would have been physically impossible to obtain in the world where the craving evolved. Your brain is still screaming for sugar, but it's screaming into a world where the thing it's screaming for is no longer scarce. The craving was calibrated for a world of scarcity. You live in a world of surplus. The mismatch is the space between those two worlds, and you live inside that space every day. The same is true for fat, for salt, for the urge to eat as much as possible whenever food is available, because for 99% of human history, the next meal was never guaranteed. Your body stores fat with ruthless efficiency, a talent that kept your ancestors alive through droughts and winters and the long, lean intervals between successful hunts. That same talent, in a world of refrigerators and drive-thrus, becomes a burden, a metabolic inheritance that no longer serves its purpose but can't be returned. You're not broken. You're a perfectly designed organism living in the wrong century. And the mismatch goes deeper than food. Think about your sleep. Right now, you're lying in the dark or near dark, but your day was probably saturated with light. Not sunlight, screen light. The blue-white glow of LEDs, of phone screens, of laptop displays, of fluorescent office tubes. Light that your brain interprets as daytime, as noon, as time to be alert. Because for the entire evolutionary history of your species, the only source of blue-white light was the sun. Your circadian rhythm, the internal clock that regulates your sleep, your hormones, your digestion, your mood, was calibrated for a world of fire and starlight. A world where darkness was total, were the only. Light after sunset came from flames that burned at the warm orange end of the spectrum, the end that doesn't suppress melatonin, the end that tells your brain it's safe to sleep. You don't live in that world anymore. You live in a world of artificial light that penetrates every hour, every room, every moment. And the result is a population-wide disruption of sleep. The same sleep your body desperately needs to consolidate memory, repair tissue, regulate emotion, and clear the metabolic waste products that accumulate in the brain during waking hours. The woman on the Euphrates slept when it got dark. She woke when the birds started. Her circadian rhythm was synchronized with the planet's rotation in a way that yours, almost certainly, is not. Not because she was wiser, not because she tried harder, because her world hadn't yet invented the technology that disrupts the signal. And then there's the noise. Not sound, stimulus. The sheer volume of information your brain processes in a single day would have overwhelmed any human who lived before the 20th century. News, notifications, advertisements, emails, social media feeds, podcasts, alerts. Each one is a small energy expenditure. Your brain burns glucose to process every input, every decision, every micro-assessment of relevance and threat. The prefrontal cortex, the part of your brain that handles decision-making and impulse control, is running at capacity from the moment you wake up. Your cortisol, the stress hormone, was designed to spike in genuine emergencies. A predator in the grass, a rival at the waterhole, a child in danger. Short, sharp, appropriate surges followed by long periods of calm recovery. In the modern world, cortisol drips steadily all day from traffic, from deadlines, from the constant low-grade threat signal of a news cycle that never turns off. Your adrenal glands are working a shift they were never built for. Not a sprint. An ultra-marathon without a finish line. On the Euphrates, the decisions were few but consequential. How much grain to ration? Where to move the cattle? Whether to stay or go? The brain had time to rest between decisions. There were long stretches of monotony, grinding grain, weaving reeds, watching the river, that functioned as cognitive recovery periods. The modern word for this is boredom, and we treat it like a disease. But it's actually maintenance. It's the brain idling, defragmenting, processing, and we've eliminated it almost entirely. You feel this. You might not have the language for it, but your body knows. The fatigue that doesn't resolve with sleep, the restlessness that doesn't resolve with activity, the vague sense that something is wrong, something is off, something doesn't fit. But you can't point to it because the mismatch isn't in any single thing. It's in the gap between the world your body expects and the world your body inhabits. The pyramid explains part of this, too. Your ancestors lived on the razor's edge of the energy budget, always a little hungry, always a little alert, always calibrated to scarcity. Your stress response, your cortisol rhythms, your appetite regulation, your tendency to catastrophize. All of these are features, not bugs. They were designed for a world where the pyramid was narrow and precarious, and a single bad season could mean death. That world is gone, but the wiring remains. And here's the strange compassion in that. If you feel anxious tonight, if your mind is racing, if your body is tense, if you can't quite let go, it's not because something is wrong with you. It's because something is right with you. Your hardware is working perfectly. It's just running software designed for a different operating system. A system of grain pits and cattle pens and seasonal drought, where vigilance was the price of survival and the ability to worry was the most important adaptation your species ever developed. You come by your anxiety honestly. 10,000 generations of survivors build it into you, one drought at a time. Breathe. Let your shoulders drop. The worry is real, but it's also inherited. A hand-me-down from ancestors who needed it more than you do. You can set it down just for tonight. It will be there in the morning if you want it back. But here's the thing about the pyramid. Here's the part of the story that doesn't get told enough. The part that sits quiet beneath all the data and the warnings and the slow drumbeat of ecological anxiety. It held through every crisis, every drought, every famine, every climate shift, every collapse of every civilization that ever stood on the pyramid's narrowing peak. It held. Not perfectly, not painlessly, not without terrible cost, but it held. The base kept photosynthesizing, the energy kept flowing, and at every point where the human story could have ended, someone, some small group of exhausted, hungry, frightened people found a way through. The woman on the Euphrates. Her community scattered when the drought came. Some died, many suffered, but the survivors, the ones who walked south to the marshes, the ones who followed the rivers deeper into the alluvial plain, they found new bases, new pyramids. They adapted their diets, their settlement patterns, their entire relationship with the energy flow of their landscape. They didn't just survive. They innovated. Under pressure, they developed irrigation. They bred hardier grain. They learned to store water, to read the sky, to predict the seasons with a precision that bordered on science. The drought didn't destroy them. It edited them. It selected for adaptability, for cooperation, for the willingness to change when the old ways stopped working. This has happened over and over and over again. It's the rhythm of human history, as regular as a heartbeat. The ancestral Puebloans of the American Southwest built a civilization in one of the driest landscapes on the continent. For centuries, they thrived, building multi-story stone dwellings, constructing road networks across the desert, developing sophisticated astronomical calendars to time their planting. They lived near the top of a very narrow pyramid in a landscape where the base was always thin, and then the rains shifted. A prolonged drought in the late 13th century, confirmed by Triering data, each ring a record of that year's rainfall, each narrow ring a year of thirst, collapsed the agricultural base. The great houses emptied, the roads fell silent. But the people didn't disappear. They migrated. They moved to river valleys, to higher elevations, to places where the water still came. They became the Pueblo peoples, the Hopi, the Zuni, the Tewa, who were still here, still farming, still telling stories, still connected to the land by threads of kinship and memory that stretch back 1,000 years. The pyramid narrowed. The people adapted. Life continued. The same pattern in the Maya lowlands, where a series of droughts between 800 and 1000 CE contributed to the decline of the great city-states. Tikal, Calakmul, Copan, their populations dispersed. Their monuments were swallowed by jungle. But the Maya didn't vanish. They're still here. Millions of them, speaking dozens of Mayan languages, farming the same soils, carrying the same genetic signatures. The same pattern in the Indus Valley, where the Saraswati River dried up around 1900 BCE, and the great cities of Harappa and Mohenjo-daro were gradually abandoned. The people moved east into the Ganges plain, carrying their knowledge, their crafts, their stories. The civilization transformed. It didn't end. The same pattern after the Black Death swept through Europe in the 14th century, killing a third of the population. The survivors inherited a world with fewer mouths and the same amount of land. The base of the pyramid, suddenly, was wider per person than it had been in centuries. Wages rose. Serfdom crumbled. The rigid social hierarchies that had seemed permanent turned out to be artifacts of a specific energy ratio. And when that ratio changed, the hierarchies changed with them. Out of the worst catastrophe in European history came the conditions that would eventually produce the Renaissance. The pyramid contracted, then it expanded, and the people who were left built something new on top of it. This pattern is so consistent, so reliable across cultures and centuries, that it starts to look less like coincidence and more like a law. Not a physics law, a biological one. The law of adaptive persistence. Squeeze a population hard enough, and you don't get extinction. You get innovation. You get migration. You get the desperate, creative, stubborn refusal to die that characterizes every species on this planet. But that reaches its fullest expression in the one species that can tell stories about what it survived. This is what humans do. This is what you're built to do. Not to hold the line. The line always moves. But to move with it. To track the energy. To follow the base of the pyramid wherever it goes, and to rebuild on whatever foundation it offers. And the tool that makes this possible, the adaptation that matters more than any other, more than opposable thumbs, more than bipedalism, more than the oversized brain that burns 20% of your metabolic energy, even when you're doing nothing, is cooperation. No human survives alone. No human has ever survived alone. The lone wolf fantasy, the rugged individual myth, the idea that strength means self-sufficiency, these are modern inventions, and they are thermodynamically absurd. A single human, alone on the savannah, is a dead human. The energy budget doesn't work. You can't hunt enough, gather enough, stay warm enough, stay alert enough. The math requires partners. It requires a division of labor, a sharing of risk, a pooling of knowledge. It requires someone to watch while you sleep. It requires someone to carry the child while you dig the roots. It requires someone to remember the route to the water source when your own memory fails. We are the most energy-expensive large animal on the planet per kilogram. Our brains alone consume a fifth of our resting metabolic budget, a staggering allocation, unmatched by any other species. We pay for that brain with vulnerability. We're born helpless. We mature slowly. Our children need years of care before they can fend for themselves. A species with this much overhead, this much energy invested in each individual, cannot afford to lose members to isolation. The economics demand interdependence. Every night, when you close your eyes, you are performing an act of trust so ancient it predates language. You are assuming that the world will not end while you're unconscious. You are trusting, without thinking about it, without choosing it, that someone, something, some structure of civilization will hold the line while you rest. On the Euphrates, that trust was literal. Someone tended the fire. Someone watched for predators. Someone kept an ear open for the sound of the river rising or the wind shifting or a child crying in the dark. Sleep was a communal act, made possible by the simple agreement that we take turns being vulnerable. That agreement is the foundation beneath the foundation. Below the pyramid, below the energy flow, below the physics, there is this, the human willingness to take turns. You are the beneficiary of that willingness right now. The electricity that powers the device you're listening on was generated by someone working a shift you'll never see. The food in your kitchen was grown by hands you'll never shake. The roads, the pipes, the wires, the invisible infrastructure that allows you to lie safely in the dark. All of it is the product of cooperation, of people doing their part of the work so that other people can rest. This is not sentimental. This is thermodynamic. Cooperation is the strategy that allows humans to operate at trophic levels that would be unsustainable for any solitary species. By sharing the energy budget, by distributing the costs of hunting, farming, building, defending, we effectively widen the base of the pyramid. We make more energy available per person than any individual could capture alone. Cooperation is our cheat code, the one loophole in the 10% rule. Not a way around the physics. The physics is non-negotiable, but a way to make the physics work in our favor. To capture more of the base, to distribute the losses more broadly, to ensure that when the pyramid wobbles, no single person bears the full weight of the collapse. Your DNA carries this. The genes for oxytocin, the bonding hormone, the one that floods your brain when you hold a child, or embrace a friend, or even listen to a kind voice in the dark. The genes for mirror neurons, which fire in your brain when you watch someone else struggle, making their pain a shadow of your own. The genes for language itself, the tool that allows you to share not just food but information, not just calories but strategy, not just energy but meaning. These are not luxuries. These are survival adaptations, as essential as teeth and lungs. The warm feeling you get when someone is kind to you, that's not sentimentality. That's your reward circuitry reinforcing a behavior that has kept your lineage alive for 300,000 years. The discomfort you feel when you see someone suffering, that's not weakness. That's your brain running a cost-benefit analysis and concluding that helping them is cheaper than losing a member of the group. Even right now, this voice in your ears, these words in the dark, this is cooperation. Someone made this so that you could rest. Someone sat at a desk and wrote these words and recorded this audio and uploaded it to a server. And someone else built the server, and someone else laid the cable, and someone else mined the minerals that went into the device in your hand. Hundreds of people, most of whom will never meet, all participating in a chain of effort that ends with you, lying safely in the dark, being told a story about energy. The pyramid of cooperation, built on the pyramid of energy. Both of them holding you up right now. You're built for this, built for each other, built to survive not as individuals, but as a web of mutual dependence, so old and so deep that you don't even notice it, the way you don't notice the air until it's gone. The fire crackles, somewhere in the deep past. The river murmurs. The woman on the Euphrates sits with her hand in the dirt and her children sleeping nearby, and she is not alone. She has never been alone. Neither have you. The pyramid wobbles. It always wobbles. But the people at its top, the fragile, warm-blooded, energy-expensive people, hold on. Not because they are strong, because they hold on to each other. That capacity is still in you, in your breath, in your blood, in the ancient wiring of your social brain. It didn't leave. It can't leave. It's the deepest thing you are. And tonight, it's enough. It's always been enough. Let's go up, not forward or backward in time. Up, above the Euphrates, above the settlement, above the grain pits and the cattle pen and the woman with her hand in the earth. Above the river's slow brown curve and the marshes to the south and the dry hills to the north. Up past the birds, past the clouds, past the thin blue margin where atmosphere becomes space. From here, the earth is a marble. You've seen the photographs. Everyone has, but photographs don't carry the silence. From up here, there is no sound. No wind, no river, no insects, no grinding stone. Just a planet turning slowly in the dark, wrapped in its tissue-thin atmosphere, catching the light of an ordinary star. That star has been burning for 4.5 billion years. It will burn for roughly 5 billion more. In the scale of its lifetime, the entire history of life on Earth is a brief flare, a few 100 million years of complex organisms clinging to the surface of a rock, running on captured photons. Let's compress it. Let's take the Earth's entire 4.5 billion year history and squeeze it into a single 24-hour day. Midnight to midnight. The whole story. The Earth forms at midnight. For the first several hours, through the small hours of the morning, through dawn, through breakfast, nothing lives. The planet is molten, then cooling, then bombarded by asteroids, then cooling again. The oceans condense for volcanic steam. The atmosphere is poison, methane, ammonia, carbon dioxide. No oxygen, no breath. The first single-celled life appears around 4 a.m. bacteria. Simple, tough, unimaginably ancient. They'll have the planet to themselves for a very long time. Photosynthesis evolves around 6 a.m. This is the moment. This is when the pyramid's base is laid, when the first organisms figure out how to capture sunlight and store it as chemical energy. For billions of years before this, energy entered the living world only through chemistry, through the thin trickle of reactions at hydrothermal vents and mineral surfaces. Photosynthesis blows the door open. Suddenly, the base of the pyramid is as wide as the sunlit surface of the ocean. Energy pours in, but the oxygen those early photosynthesizers produce is toxic to almost everything else alive. It takes billions of years, most of the day, in our compressed clock, for the atmosphere to fill with oxygen, for the ozone layer to form, for the conditions to exist that will allow complex life to emerge. Complex multicellular life doesn't appear until around 8:30 p.m. You've been awake all day, and animals are just now showing up for the evening shift. The Cambrian explosion, the sudden proliferation of complex body plans, of eyes and shells and claws and spines, happens around 9 p.m. The dinosaurs arrive at about 10:40 p.m. They dominate for roughly 45 minutes. Then, at 11:39 p.m., an asteroid hits the Yucatan Peninsula, and they're gone. The first primates appear in the last half hour before midnight. The forests are warm and wet and dark. The sound is rain, constant rain, dripping through a canopy so dense that sunlight reaches the forest floor and scattered coins of gold. The smell is decomposition and growth, so intertwined they're indistinguishable. The same smell the woman will know on the Euphrates, the same smell you know if you've ever walked through old woods after a storm. In those trees, small animals with grasping hands and forward-facing eyes are learning to judge distance, to leap between branches, to see the world in 3 dimensions. Their brains are growing. Their energy budgets are tightening. The 10% rule is already squeezing them. They need more calories per gram of body weight than almost any other mammal, because the brain is expensive and the brain is getting bigger. The first members of the genus Homo, your direct ancestors, appear at roughly 11:58 p.m., 2 minutes before midnight. Agriculture, the woman on the Euphrates, the grain pits, the cattle, the entire revolution that remade the human relationship with the energy pyramid begins at approximately 1 second before midnight. 1 second, the Roman Empire, the Han Dynasty, the rise of Islam, the Crusades, the Renaissance, the Industrial Revolution, both world wars, the moon landing, the internet, your birth, this moment right now. All of it fits inside that single second. A fraction of a fraction of the day. Feel that, not as a fact, but as a sensation. Feel the weight lift. Feel the scale of it dissolve the edges of whatever was pressing on you today. The deadline, the argument, the bill, the worry that sits like a pebble in your shoe. Your problems are real. They matter. They matter to you. And that's enough to make them matter. but they are also temporary. They are 1 second's worth of trouble in a day that started with fire and stone and the slow, patient accumulation of an atmosphere that could sustain your lungs. The pyramid, Lindemann's pyramid, the energy flow, the 10% rule, has been operating since 6 a.m. on our compressed clock. Since the first photosynthetic bacterium split a water molecule and captured a photon. For 18 hours of planetary time, energy has been flowing from sun to life, bleeding away at every transfer, narrowing the pyramid at every level. And yet, life has persisted, has diversified, has complexified, has produced, in its final second, an organism that can lie in the dark and contemplate the whole extraordinary process. That organism is you. You are not separate from the pyramid. You are not on top of it, looking down. You are inside it. You are made of it. The carbon in your bones was fixed by photosynthesis. The iron in your blood was forged in a star. The calcium in your teeth, the same calcium that was in the bones of Lindemann's lake fish, the same calcium that was in the shells of the Cambrian trilobites, has been cycling through living organisms for billions of years, passing from body to body, from pyramid to pyramid, accumulating and dispersing and accumulating again. You are not a visitor to this system. You are a wave in it, a brief, particular pattern in the endless flow of energy from star to life to heat. And right now, in this moment, the wave is cresting. You are here. You are conscious. You are warm and fed and listening to a story about why you're warm and fed. The pyramid is holding you. The sun, which set hours ago wherever you are, is still feeding you through the stored energy in your cells, through the food in your stomach, through the electricity in your walls. Even in the dark, the star sustains you. Let that be enough for tonight. Let the scale of deep time do what it does best. Not diminish you, but release you. You're small, yes. Unimaginably small against the backdrop of 4.5 billion years. But you are also here, which is something that the vast majority of possible humans, the ones who were never conceived, never born, never got their second of the clock, cannot say. You are the one who made it. You are the second before midnight, awake, breathing, aware. That's not small. That's everything. Let's talk about the odds. Not in the abstract. Concretely. Specifically. The odds of you. Start with the sun. If the sun were 10% more massive, it would burn too hot and too fast for complex life to evolve on any planet in its orbital zone. If it were 10% less massive, the habitable zone would be so narrow that the Earth would need an almost impossibly precise orbit to stay within it. The sun is within a thin margin, exactly the right size. Not by design, by the same blind, patient selection that governs everything. The ones that weren't the right size didn't produce planets with listeners on them. Now the Earth, the right distance from the right star, a magnetic field strong enough to deflect solar radiation, a moon large enough to stabilize the axial tilt, preventing the wild climate swings that would make agriculture, and therefore civilization, impossible. Liquid water, plate tectonics, an atmosphere that traps enough heat to keep the oceans from freezing, but not so much that the surface becomes a furnace. None of this was guaranteed. None of this was planned. It happened. And because it happened, the pyramid could be built. The base could be laid. The energy could flow. Now the ancestors. Every organism that has ever lived is your ancestor if you go back far enough. But let's start closer. Let's start with the first humans, the small, scattered populations of Homo sapiens in eastern Africa, roughly 300,000 years ago. There may have been as few as 10,000 of them at certain points. 10,000 on a continent the size of Africa. A handful of embers in an enormous dark room. Each one of them survived long enough to reproduce. Each one found food, avoided predators, fought off disease, endured drought, endured cold, endured the 1,000 daily indignities of a life lived without shelter, without medicine, without any guarantee that tomorrow would come. And each one, at least once, found a partner and produced a child who also survived. The chain is unbroken. 300,000 years. Roughly 15,000 generations. And not once, not a single time, did the chain break. Not during the Toba supervolcanic eruption roughly 74,000 years ago, when the sky darkened with ash and global temperatures dropped and the human population may have crashed to a few thousand individuals. The air after Toba would have tasted of sulfur and chalk. The sun, for months, would have been a pale disk behind a veil of particulate matter, giving light without warmth. The plants died back. The base of the pyramid shrank to almost nothing, and somewhere in a cave or riverbank shelter, a handful of humans kept a fire going and ate whatever they could find and waited. They waited, and the sky cleared, and the plants came back, and the pyramid rebuilt itself, photon by photon, leaf by leaf. Not during the last glacial maximum, roughly 20,000 years ago, when ice sheets 2 miles thick covered northern Europe, and sea levels dropped by 120 meters and the habitable land shrank to narrow corridors along coastlines and river valleys. The cold was not the cold of winter. It was the cold of a different planet, relentless, structural, the kind that reshapes landscapes and kills rivers and turns forests into tundra. The smell of the Ice Age was the smell of dry air and stone. No moisture, no green, just a mineral tang of glacial dust blowing across treeless plains. Not during the countless local famines, floods, epidemics, and wars that don't appear in any history book because they happened before history existed. Someone made it through. Every time. Someone found enough energy at the base of the pyramid to keep breathing, keep moving, keep the species going. Someone shared their food when they didn't have to. Someone carried a child through a landscape that was trying to kill them both. Someone stayed awake through the night, watching for danger so that others could sleep. And you are the living proof that they succeeded. Think about that. Not as a motivational poster, as a fact, as a cold, verifiable, biological fact. You exist because an unbroken chain of survival stretches from this moment back to the first cell that figured out how to divide. Every link in that chain held. Every ancestor survived. Every crisis was weathered. Every narrowing of the pyramid was endured. The probability of this, of you specifically with your particular combination of genes, your particular face, your particular voice, your particular way of falling asleep, is so vanishingly small that mathematicians don't have a useful way to express it. It's not 1 in a million. It's not 1 in a billion. It's a number so large that writing it out would take more ink than exists. And yet here you are. Your heart is beating. roughly 60 to 80 times per minute, depending on how relaxed you are. Each beat pushes blood through approximately 60,000 miles of blood vessels, enough to wrap around the earth more than twice. That blood carries oxygen captured from the air by your lungs, which expand and contract roughly 20,000 times per day without you ever deciding to breathe. Your immune system, right now, is identifying and neutralizing threats you'll never know about. Bacteria, damaged cells, rogue proteins, in a silent, ceaseless campaign of self-maintenance that has been running since before you were born. All of this costs energy. All of this is the 10% rule in action. Your body burning through the captured sunlight of your last meal, converting it to heat, to motion, to thought, losing most of it to the room around you, keeping just enough to sustain the pattern, to maintain the wave, to hold you here for one more breath. The energy that keeps you alive tonight was sunlight. Remember that. The bread you ate was sunlight. The chicken was sunlight twice removed. The salad was sunlight and water and minerals drawn up from the soil by roots that will never know your name. You are a cathedral of converted starlight, lying in the dark, listening to the story of how cathedrals are built. And the fact that you can hear this, that your brain can process language, can summon images, can feel emotion in response to words spoken by a stranger, is itself a miracle of energy allocation. Your brain, that 1.5 kilograms of wet tissue behind your forehead, burns roughly 20% of your total caloric intake. 1/5 of everything you eat goes to maintaining the organ that allows you to wonder about what you eat. The recursion is beautiful. The cost is enormous. And your species has been paying it for 300,000 years because the brain, with its capacity for language, for planning, for cooperation, for storytelling, is worth the expense. It is the tool that widens the base of the pyramid for everyone. That brain is winding down now. You can feel it. The thoughts softening at the edges, the grip of attention loosening, the body getting heavier as the parasympathetic nervous system takes over and begins the slow, gentle work of pulling you towards sleep. This is ancient too. This surrender, this nightly rehearsal of trust, of letting go, of allowing the body to do its maintenance work in the dark while the conscious mind steps aside. Let happen. You've earned it. Every ancestor who survived earned it for you. The room is dark, or nearly dark. There's always some light now, some faint glow from a street lamp or a standby LED or the ambient radiance of a city that never fully sleeps. But close enough. Dark enough for the melatonin to rise, for the muscles to unknot, for the thoughts to lose their edges and become soft, round, drift-shaped. Somewhere, the woman on the Euphrates is sleeping too. Not in your time, in hers. 9,000 years away. But the sleep is the same sleep. The same neurotransmitters. The same slow descent through the stages. Light sleep to deep sleep to the strange, vivid country of REM, where the brain replays the day and files it away and makes meaning from fragments. She dreams of the river, perhaps, of the grain, of her children's faces in firelight. You dream of your own equivalents, the things you tend, the things you protect, the things you carry. The dreams are different. The dreaming is the same. The fire is going out. Not your fire. You probably don't have a fire. But somewhere in the deep architecture of your brain, and the part that still listens for predators and watches for the glow of embers. A fire is banking itself for the night. The coals are settling. The flames are shrinking to a blue whisper. The heat remains, but the light is fading. This is the oldest human ritual, older than language, older than art, older than burial, older than music, older than every ceremony and sacrament that any religion has ever devised. The tending of fire and the letting go of fire. The moment when the day is done and the fire is allowed to die and the darkness is allowed in, not as a threat, but as a blanket. You've been with me for a while now, across 9,000 years and 4.5 billion, across the Euphrates and Silver Springs and the ice cores of Greenland, across the pyramid, from the photons at the base to the warm breath at the top. Thank you for that. I mean it simply, without performance. You gave your time, which is a form of energy, the rarest form, the one you can't get back. Some of you are still awake, and I'm grateful for your attention. Some of you fell asleep an hour ago, maybe two, and I'm grateful for your trust. You let a stranger's voice follow you into the dark. That's not a small thing. The 10% rule. That's what we came here to talk about. And maybe it sounds clinical now, a dry fraction, a physics problem, a number in a dead man's paper. But I hope it sounds like something more. I hope it sounds like the taste of bread baking on a hot stone, like the weight of a sediment core in gloved hands, like the hum of a mass spectrometer reading the diet of someone who died 3,000 years ago, like the smell of cattle at dawn and the sound of grain being ground and the feel of dry earth under a mother's fingers as she calculates, without numbers, whether her children will eat next month. The 10% rule is not an abstraction. It's the texture of being alive. It's the cost of warmth, of thought, of love. It's the reason you ate what you ate today, and the reason your ancestors planted what they planted, and the reason the woman on the Euphrates watched the wind and held her breath. And it's the reason you're warm right now. That heat, the heat under your blanket, the heat in your cheeks, the heat in the slow pulse at your wrist, is the universe's tax on your existence. You are paying it right now, and you'll pay it with every breath until your last. And it's worth it. Every radiated photon, every calorie of waste heat, every fraction of a degree lost to the air around you. It's worth it. Because you're here. And being here, even for 1 second before midnight, is the whole point. The woman on the Euphrates is gone. Her name is gone. Her language is gone. The shelter she slept in has been mud again for 9,000 years. But her mitochondria, the tiny organelles in her cells that burn fuel and generate heat, that pay the energy tax on her behalf, are your mitochondria. The same ones, passed down through an unbroken maternal line, mother to daughter to mother to daughter, for millennia. She's in you right now. In every cell of your body, her furnace is still burning. Rest now. The pyramid will hold through the night. The sun will rise in a few hours, and the base will widen again, and the photons will pour in, and the plants will catch them, and the ancient engine of energy flow will turn over one more time, the way it has every day for 4 billion years. You don't need to hold it up. You don't need to solve it. You don't need to worry about the supply chain or the climate or the price of grain. Not tonight. Tonight, you could be what you are, a warm body in a dark room, breathing in and breathing out, carrying the genes of 10,000 generations of people who made it through. If you'd like to come back, we'll be here. Every week, another story, another fire, another slow walk through the deep past. Subscribe if you want to see by the fire next time. Leave a comment and tell me where you listen from at night. I read every one, and it still surprises me every time how many different darknesses you're all lying in. Someone in Manila at 3 a.m., someone in Edinburgh at 10 p.m., someone in a parked car in a hospital lot, waiting for news, needing something steady in their ears. I think about you, all of you. The fact that you chose to spend your time here, in this particular corner of the night, listening to a story about energy and grain and a woman who lived 9,000 years ago. That means something to me. It means you're curious. And curiosity, if you think about it, is just the brain's way of widening its base, of reaching for more light. But not now. Now is for quiet. Close your eyes if they're still open. Let the weight of the day drain out through the soles of your feet. Let the 10% rule do what it does. Let your body radiate its gentle heat into the night. Let the energy flow. Let the physics run. You are part of the current. You always have been. The fire goes to embers. The river murmurs. The insects sing their one long note. And somewhere, 9,000 years ago, a woman finishes her evening work and lies down on a reed mat and places her hand on the ground and feels, through the packed earth, the faint vibration of the river. And she closes her eyes, and the stars are so bright, brighter than you have ever seen them, brighter than you can imagine, a sky so full of light it looks like something spilled. And the children are breathing, that soft, steady, unconscious rhythm that is the most reassuring sound any parent has ever heard. And the grain will last another month. And the cattle are safe in their pen, their bodies warm and heavy, their slow breathing mixing with the sound of the river. And the fire is low, just a glow now, just a memory of flame, held in the orange heart of the coals. And the night is kind. The night has always been kind, if you let it be. If you stop fighting it and lie down and let the dark hold you the way it has held every human who ever lived, every night for 300,000 years. You're held now, by the dark, by the story, by the unbroken chain of survival that ends tonight with you. Rest well. You are a descendant of survivors. And tomorrow, the story continues.